The next thing I want to cover is, well, how do we add or subtract rational functions when the denominators are not the same? What do we do? Because as I said in the last video, they must have the same denominator in order for you to add them. It will not work otherwise. So this first step is to make sure that both rational functions have the same denominator. And let's say we're looking at fractions, because I like to always compare it back to basic fractions, because the math is exactly the same. It's only, we just have to apply our polynomial thinking to it. But let's just say we had 3/7 and we wanted to add that to 1/4. In order to add those together, we need to make the denominator the same. And in this particular example, that can be done by simply multiplying each one by the opposing number, right? Because, well, if they're two different numbers, I just can multiply them together, and that will create a common denominator of 28. And we can use the equivalent fraction principle, since I'm always allowed to multiply a fraction by whatever I want if I do it to both the top and the bottom, because that will remain equivalent by that equivalent fraction property, which was the same property we were using to simplify. And after I do all that, I'll create a common denominator. But basically, this is the idea of what we call a common denominator, and finding what's called the least common denominator is an important thing to think about. So what I wanted to do is look at a couple examples of rational functions and try to determine the common denominator, or even better, the least common denominator in those cases. And what it says to do is first factor the denominator of each one completely. And then here's my recommendation, is to then look for what are all the shared factors, all the unshared factors, and bring all them together. And so let's apply an example with numbers. Let's say we were trying to take 1/10 and add that to 7/15. We could just multiply 10 and 15 together, as I was saying below, but that's actually going to that's more work than is required, because really the LCD here is 30. It's an easier way to match those numbers, basically. And the way you could find the LCD is, a lot of you guys might be able to just sort of figure it out, but there is a strategic methodology, which is to, as it says here, to factor each number completely. In this case, 10 is 2 times 5, 15 is 3 times 5. And then I want to take all of the shared factors, 5, sorry, you can't see that, and multiply by each of the unshared factors, which is 2 and 3. And if I take 5 times 2 times 3, that will give me, basically multiply all the shared. You don't duplicate the shared, you only use them once, unless it's shared more than once. But that would give me 10 times 3 is 30. And this would be the LCD for that problem. And in this case, I could always then take each of those numbers and multiply by the missing factor, like 15 from the LCD, because the LCD is 5 times 2 times 3. 15 is just 5 times 3, so it's missing the other one. And making a little chart like this can help you identify what is the LCD, and also help you determine how to match them up. But let's do it with polynomials. So for example, looking at 4x squared and 6x cubed, we could make a factor tree here, because technically these polynomials are monomials. They're singular terms. You can't factor them in the polynomial sense, but we could still look at it as, well, 4x cubed, that's, 4x squared is, well, of course, that's 4 is 2 times 2, but also x is x times x. So I could look at it as, well, two of the factors I know here, two of the factors I don't know. When it comes to 6x cubed, 6 factors as 2 times 3, and x cubed is, of course, x times x times x. And I could apply that same sort of thinking to figure out what the LCD is, because clearly 2 is a shared factor, as are 2 x's. Those are all shared factors in green. And then the unshared factors I'll do in purple would be 2, 3, and x. And if I multiply all the green times all the purple, I would have 2 times x times, or 2x squared, which is the common factor, right? If you were thinking about factoring out the GCF, that is the GCF from green to x squared, right? Because they both share 2, they both share a squared. And whatever's left over is multiplied together, which is 2 times 3 times x, 6x. Because this one had a 3 and an x extra, and this one had a 2 extra. And that would leave me with 12x cubed as the LCD for those two denominators. And of course, you could think about that, well, this one is missing a 3 and an x. This one's missing a 2. Either way, you figure out what is missing from one in the other, and then you multiply that in. And that's another way to find your LCD. So looking at another one, and this, again, we can see why factoring is important here. Like with 4x minus 24, if we were to factor each one of those, that would factor as, and again, we only care about the denominator, not the numerator. 4x minus 24 would factor as 4 times x minus 6. And with 2x minus 12 would factor as 2 times x minus 6. So we can see is that x minus 6 and 2 are shared, 4 is unshared. Sorry, 2 is unshared from the other one. So the LCD here would just be 4 times x minus 6 for the same reason. And also notice since 2 was shared, I extracted one of the 2's and the x minus 6, and I had to keep the other 2. But essentially, this one's a little bit easier because I could imagine if I just multiplied this one through by 2, that would match. It's easier. So sometimes the LCD could be actually just equal to the entire denominator of one of them, and that makes it a little easier. Now looking at some rational functions with quadratics in their denominator, again, we would want to first factor each of those denominators. So the first one would be x plus 2 times x plus 2. In the second one, it would be x minus 8 times x plus 2. And again, the LCD should be the list of shared factors times the unshared factors. So x plus 2 is shared. Again, I'll circle that in green. Shared, or I'll underline it, whatever. And then the unshared, I'll underline in purple, would be the second x plus 2. And this is another thing I wanted to mention is that in order to be shared, it has to be in both. But even though there was an x plus 2 in this one, there wasn't 2. So the secondary x plus 2 is not shared by the way I'm defining it. So we need to include both another x plus 2 and an x minus 8 in the LCD, which would be all 3 of those. And again, finding the LCD is very critical because if I'm trying to add together rational functions that do not have a common denominator, I need to first match them, like I said over here. First, we need to match. Once they're matched, we're good to go in terms of progressing through adding and subtracting.